Is it visible, my screen?
Yes, sir.
Okay. Okay, so last time we did that how to solve a system of linear equations, and we discussed also about the systems of linear equations. So today I will be a bit discuss about the eigenvalue and eigenvector, and then I will move to statistical methods. So I think ma'am taught you about the statistical methods. I think she started, right?
Yes, sir. Yes, sir. She is.
So what are the topic have been covered till now?
We covered standard deviation, standard error, and all. We are now in binary data and also.
Okay, so the basic descriptive statistics, I think she has covered. So, okay, so today I'll start with eigenvectors and eigenvalues. So already it has been taught to you. So can you please give me a basic idea about what is a eigenvalue of a matrix? Can you give me any basic idea?
Eigenvalue and eigenvector are for where imaginary terms, I mean, multiple results can be seen. Infinitely many values will be present, sir. So then get into a term where we bring in a variable times the number of.
No, just the what do you mean by an eigenvalue of a matrix? So you are calculating eigenvalue of a matrix. So what does it mean? I mean, what is the definition of eigenvalue? Or
The,
can you please tell me the equation of how to calculate suppose I am giving you a vector capital A. So how you can calculate eigenvalue of that vector?
1 second, sir.
Yeah.
You're asking me for an eigenval, how to calculate the eigenvector, sir?
No, first eigenvalue. How you can calculate eigenvalue? Then I will come to eigenvector.
For eigenvalue,
Suppose I am giving you one vector capital A. Okay, so how you can calculate? So already I think I taught you. Suppose the capital vector A that is equal to 3, 2, 1, 5, 4, 7, and 8, 9, 10. Suppose I am giving you this vector A. So how you can calculate eigenvalue of this vector? Using MATLAB, can you tell me how you can? I also taught you, I told, I mean before that how we can calculate eigenvalue.
I
Using
don't
MATLAB?
know.
Okay, so you just type IIT function of capital A and it will give you 3 eigenvalue of this vector. So in that case, in MATLAB, you don't have to know what is the eigenvalue and all those things. Still, you can able to calculate eigenvalue using this EIG function or IIT function. But but we should know about what does this eigenvalue means. I mean, why there is only 3 eigenvalue. Okay, so to discuss so that is why I want to know that I want to know actually how much you know about this eigenvalue and eigenvector. That thing I want to know, otherwise I will discuss it. Anyway, I will discuss, but just the basic idea that what is a eigenvalue or how we can calculate it. Like this MATLAB calculate this in this way, so manually how you can calculate these values.
So the number of free variables minus 1 will be the number of it. So the free variable will be the one.
What do you mean by free variable?
Free variable is any number can be replaced for that.
Okay, but what is the basic formula for calculating eigenvalue?
Okay, formula. Okay, sir. Det into a minus lambda I is equal to 0.
Lambda into date of?
Det of a minus lambda I is equal to 0. It's a characteristic equation of a matrix A.
Okay, yeah, that is the thing. But and uh, in this equation, which is the eigenvalue?
Eigenvalue is lambda, sir.
Okay, lambda. And what is this I vector?
I is identity matrix, sir, which we multiply with it.
Okay, okay, yeah, that is the correct definition. So see here you can see actually eigen value, eigen means characteristics. Okay, so suppose A is a linear system, so we can get the idea of these characteristics of this system using eigenvalue and using eigenvector, and eigenvalue or eigenvector are related to each other. Okay, so so this is the definition. Suppose A will be an n cross n by n matrix. So an eigenvalue of A is a non-zero x such that A into sorry, it is the eigenvector. So this is the basic equation. Delta is some scalar value. If we multiply A into x, so already we know that a system is Ax equal to B. This kind of system we have discussed, like this is a linear system. Instead of B, if we multiply some value and with the same vector, and the result is Ax equal to lambda into x, this equation is satisfied. Then we called this lambda is eigenvalue of this vector A, sorry, of this matrix A, and this x is the eigenvector corresponding to this eigenvalue of lambda. Okay. So
Yes, sir.
the scalar lambda is the corresponding eigenvalue. So suppose suppose this is the example that this is some eigenvector. Okay, so we have to check whether this eigenvector is this is an eigenvector of A or not. So how you can check? So we just use this equation. So we multiply A into eigenvector. So A into eigenvector we multiply, and we got the result 4 into x. So 4 is here any scalar. Okay. I mean there is 4 minus 8. So if you extract 4, so it will become 1 minus 2, right?
Yes, sir.
So Ax equal to 4x. So this equation is satisfied. So then we can tell that x is a eigenvector of A with eigenvalue 4. That means A is the matrix and its one of its eigenvalue is 4 and its corresponding eigenvector is 1 minus 2. Okay, now that equation you have just told, you can get that equation if you take this lambda into x this side, then it will become ax minus lambda into x. You got it? Ax minus lambda into x. Then you just extract x and put all the term in a third bracket. Then it will become whatever what you told just before. It will become a minus lambda into I into x. So
Yes.
that is the equation for eigenvector and eigenvalue. Now if we only concentrate on the determinant, that is a minus lambda into I, its determinant, if we only concentrate, then that determinant, if we solve the determinant, it will give us an equation. Okay, and what will be the degree of that equation? The degree of that equation will be order of this matrix. So remember, we are calculating eigenvector can be calculated only for the square matrix. So for square matrix, row and column are same. So hence we can call order of A is n. Okay. So that degree of that characteristics equation should be n. So hence we can tell that this A will have n number of eigenvalues. Suppose this is the 2 by 2. So the what is the order of this A? It is 2. So then we will tell that the A has 2 eigenvalues. So one of them is 4. Now how we can calculate this eigenvalue? So can you please calculate the eigenvalue of A using that formula A minus lambda into I, and tell me what are the eigenvalue?
1 second, sir. Is it +8, sir?
It will have two equations. It will have two value. It will be. I mean, A has two eigenvalues. So
Yeah.
one of the eigenvalue should be 4. So you just do this thing, A minus lambda into I, and take the determinant and solve it.
Yes, I'm just doing it, sir.
Okay.
Can you show the problem, sir?
Yeah.
0 minus 2 minus 4 2.
You can use MATLAB also. You don't have to manually calculate.
Our MATLAB license is expired, sir. We don't have it. We are not able.
Oh,
And
so
ERP is closed, sir. Our mails aren't working. We're trying to contact them.
you don't get your institute mail ID till now.
We got it, sir. We are not able to access it at all, sir. We tried calling them also. The ERP wasn't working at that time. Even today, we tried to access the.
Actually, what you have to do, actually you have to activate your mail ID just by changing the password from ERP. Only then you can access that mail ID, because whenever you are trying to use that mail ID for activating MATLAB, it will give one, it will give one link in your institute mail ID, but you cannot access until and unless you activate your mail ID.
Yes, sir. We
So
got that code, sir, but when we type it, it's just showing loading, sir. It's not getting loaded at all, even if it takes a whole day.
then in that case, one thing also you can do, you just go to the CIC of IIT Kharagpur.
No, sir.
It is the Computer Informatics Center for IIT Kharagpur. So
Okay.
it has here one software. Okay.
Okay.
So you will go there, or otherwise there is one tab also. So, so yeah. So there is a MATLAB. Okay. So from here you can get MATLAB campus license, or outside campus you have to click this. So access MATLAB license server from outside campus. So there is a procedure. So you can follow this procedure and try.
Okay, sir. I'll just do it today, sir.
Okay. And if it is not working, then you can contact with you have to mail not in the ERP, you have to mail in CIC. So they are responsible for MATLAB and all. So, and even you can download it from here. Okay, so MATLAB version you can download,
Okay, sir.
like software support, I think, or some other. um there is a software repository. There from you can download the all the software also. I don't know what is the tab there is. And if it is not work, then just mail to this help desk. Okay, calculate it and just 1 second.
Hello, sir. Hello. 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 Are you able to hear me, sir? Hello. Sir, are you able to hear me? Sir? Sir? Hello? 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 Hello, sir?
Yeah, yeah.
Sir, you're able to hear me, sir?
Yeah, I'm able to hear you.
I'm so sorry, sir. There's a power cut here. That's why. But
What happened?
power cut, sir. That's why I. The call got cut, sir.
Okay, okay. So are you able to calculate that?
Are you able to hear me, sir? Hello?
Yeah, yeah.
Am I still on the call? Hello?
Yeah, you hear me?
Yes, sir. The network is very thready, sir. I'm sorry about that.
Okay. In that case, you can reconnect also.
Sir, now we have to calculate the eigenvalue for 0, -2, -4, 2 into 1, 1 and -2, sir.
No, no. You have to calculate eigenvalue for only this
Only
equation. Yeah, you don't have to bother about eigenvector. This is eigenvector. Right now, I'm interested only in eigenvalue. So how you can calculate? You just put determinant inside the determinant a minus lambda into I. So just calculate. So orally also you can calculate. So this minus lambda into I. So lambda into I, what it become? Lambda 0, 0 lambda, right? Only the diagonal.
lambdas.
Only the diagonal will become lambda. So 0 minus lambda, it will become minus lambda.
Minus
Minus 2,
lambda,
it will
-2,
it will be
-4,
minus 2,
and 2
minus
minus
4.
lambda.
So 2 minus lambda. Then if you put if you calculate determinant, so what it become? So 2 minus lambda into minus lambda. Minus
Yes.
of minus 4 into 2.
-2 plus lambda square.
Yeah. So it
-8.
will generate one second order polynomial equation. So that equation you tell. What is the equation?
Lambda square -2 lambda -8.
So now solve that equation by putting by equating it with 0.
Lambda is equal to -2 and +4, sir.
Minus 2 and plus 4. So just now I have calculated the eigenvalue of A. Okay, so it is give me the same result, minus 2 and 4. But now you understand how to calculate it manually. Okay, so you have just calculated manually and I calculated here using this IIT function. Now corresponding each, so these two are the eigenvalues for this matrix. So for each eigenvalue, there is a corresponding eigenvector. So for 4, what is the eigenvector? So it is showing here 1 minus 2 is the eigenvector for the eigenvalue of 4. Now can you calculate using this equation what will be the eigenvector for -2. What will be the eigenvector for -2? You just calculate it by using this equation, ax equal to lambda into x. So you just put a here, x will be like that. You got my point? Here, see, here it is given eigenvector and they are calculating eigenvalue out of it using this equation. Now using the same equation, I am telling you that one of the eigenvector of this A is -2. Then you have to calculate what is the eigenvector corresponding that eigenvalue -2. Are you able to calculate?
Yes, I'm calculating, sir. I'm getting it as 2 into 1 and -2 in the matrix, sir.
Tell me what is the matrix? What is the vector? You should get this kind of vector.
Yes, sir. 1 and -2, sir.
No, 1 and -2 is for 4. For 4 eigenvalue, it will be 1 and -2. But for -2, it will be different. Okay,
I'm just a little confused, sir. Can you just solve?
Okay. So I orally solved it. Okay. So see, if you multiply a into that eigenvalue, it will become 0, 4 and 8 minus 4. Now, if you multiply a into that the same thing. I mean 1 1 1 1. This eigenvector, it will give you this -2, right? So minus 2 this vector. So that means these two into a. Okay, if I multiply, so if sorry, not a 1 comma 1. So this is also give me the same thing. Now you just compare this thing with this equation, a into x. Okay, a into x here, a into x. So what is the x vector here? Tell me.
1
X
and 1.
vector is 1 and 1. Okay. Now you multiply with, now you put this -2 into x. So here -2 into x. So it will give you the same result.
-2, yes, sir.
Yeah. So this equation is satisfied. A into lambda is equal to lambda into x. Sorry, a into x is equal to lambda into x. So these two equation is satisfied. Then I can tell this one on this vector is the eigenvector corresponding to -2. Okay. So what is the
Okay, sir, okay.
conclusion? So the conclusion is A is a matrix. Then if we calculate, so it is what is the order of this matrix? It is 2. That means this matrix has 2 number of eigenvalues. We calculate it manually. We got the eigenvalue 4 and -2. Also we can calculate it with using EIG function. After calculating eigenvalue, now we are interested to calculate eigenvector corresponding to each eigenvalue. So for the eigenvalue of 4, they have used, so for calculating eigenvector always always use this equation. Okay, this is the basic equation for calculating eigenvector. So so using this equation, we calculate eigenvector for eigenvalue 4 and eigenvalue -2. You understand? Okay.
Yes, sir.
So suppose, see, suppose A is a matrix. Now A into this equation, so this is equation A into x equal to lambda into x. See this equation. So what does it mean? It means that, sorry, what does it mean? This x is a eigenvector with eigenvalue lambda into lambda equal to 1. Okay.
Okay, sir.
Now this A has another eigenvalue that is -1. And what is the corresponding eigenvector for -1? It is -1, 1. How we can get? We just use this equation. A into x is equal to lambda into x. So it satisfied this equation. Then we tell -1 is another eigenvalue of A and its corresponding eigenvector is 1 -1. Now what is the effect of this? So we already know that we can this vector, it is a point in a plane xy. So suppose this is a xy, this is xy, sorry, this is xy, this vector is xy. This vector is this red line, this vector. Now if we multiply A, if it produce the invertibility, that is xy, it inverted, it became yx. What is the geometrical significance of this? So geometrical significance of this, it produce
Direction change.
its direction is changed using through the line. So it is a reflection. So it is the mirror reflection. And what is the about what line? This y equal to x, this line. With respect to
About
this
the same.
line, yeah, about, so y equal to x always moves through the center. So with respect to this line, it changes, it reflected its vector. I mean, this vector is reflected.
Like a mirror reflection.
Yeah. So that means that its length is changed. No, its length is not changed. So the same thing. So the same thing here it is also not here. 1 - 1. Yeah, here So see, this eigenvalue, what it does, this eigenvalue, when you multiply A into this vector, suppose -1, 1 is this vector. Suppose you just consider, I'm not going to the, it is a general picture, you have to draw. So this vector is this. If we multiply a matrix A with this vector, what it will produce? It just invert it or reflect it. So what it become? -1, 1 become 1 minus 1. Okay, so it produce this. And what is the, so this vector is, so these two vector, that is -1, 1, this is the eigenvector for corresponding eigenvalue -1. So what does it mean? So eigenvector, so this is a eigenvector for this. This is the real vector A and this is the eigenvector for this A. Okay, it is the geometrical significance. So we are not going to much detail about it. Okay, so just now, so you can also write it down or you know this thing. From this is the equation Ax equal to lambda x. So from this equation, we get this equation Ax into lambda into I into x equal to 0. Okay, so this equation and this equation, those two are same equation. So when you are told to calculate eigenvector, you have to use this equation either or you have to use this equation. Now this equation, if you put determinant with this, so det of a minus lambda I, and you equate it with 0, then this equation is your characteristics equation. By solving, why it is called characteristics? Because eigen means characteristics. So this by solving this characteristics equation, you will get the value for your eigen. You will get the eigenvalue. Okay. So if you are told to calculate eigenvalue, you use this equation. If you are told to calculate eigenvector corresponding every eigenvalue, then you have to use this equation. And using MATLAB, so okay. So here is an example how you can calculate eigenvector eigenvalue. So this is our vector A. So you don't have MATLAB, right? Okay. So for
no, sir, but I'm trying in that CS, I think.
Okay. So can you please calculate what is the eigenvalue for this? Your idea is clear, na? That is what I'm trying to tell. So using MATLAB, we can calculate very easily. Three, 1, 1, 3.
So lambda square
Yeah.
minus 6 lambda plus 8.
Yeah. Lambda square minus 6 lambda plus 8 equal to 0. Now you solve it. So it will give you lambda 1 equal to 2, lambda 2 equal to 4. So you
Yes.
you are able to get this equation. That means now you are clear about how to create characteristics polynomial of A. So this is the characteristic polynomial of A. If we calculate the root of this equation, so it is the order 2. That means it has two roots. So also this order of A is 2 by 2. I mean 2. So it has two eigenvalue. So its eigenvalues is 2 and 4. Now for eigenvalue lambda 1 equal to 2, how you will calculate eigenvector? So you have to use this equation. A minus lambda 1
Yes.
into I. Okay. So put 2 instead of lambda, put 2 instead of lambda 1. So you will get 1, 1, 1, 1, this equation.
Yes, sir.
Okay. So now you will solve it. If you multiply one vector x using it and you will get a 0 by 0 matrix, then you will get this vector. So this vector is your corresponding eigenvector. Okay. So sometimes in that case you have to manually you can inspect that what are the element. If we multiply it, then it will give me this same vector. Okay. So in this way, so if you go through this example, you will able to calculate eigenvalue and eigenvector.
Yes, sir.
This is very important. Suppose you are given this triangular matrix. You know what is the triangular matrix? It is the either it is upper or it is
Yes, sir.
lower.
Upper or
Value will
lower
be 0.
triangle.
Yeah. So for a triangular matrix, it is very easy to create the eigenvalue. What it become? So this is a triangular matrix.
Yes,
Now
so we have
for
to just
any
equate the values.
no for any triangular matrix, its diagonal element is the eigenvalue. So what is the eigenvalue for a 362? Now if we calculate manually using this equation, det of a minus lambda into I, you will get these three value 236, 236. Okay. So you don't have to calculate. Whenever you are given any diagonal, any triangular matrix or any diagonal matrix, its diagonal value will become the eigenvalue. Okay. So this line is very important. You can write it down. The eigenvalues of a triangular matrix, here you can also write for a diagonal also, are its diagonal entries. Okay. So this is the brief discussion about the eigenvalues and eigenvector. You can solve 2-3 problems. You can go. I shared this document with the files, so you can go through this thing. Or ma'am's note you can also go through. It will become the clear. And you just do this practice problem. Just calculate eigenvectors and eigenvalues for this matrix. Okay. It will be until and unless you are solving, it will not become clear. Okay.
Yes, sir.
Okay.
Actually, we used to solve it only, sir. We had an exam also. Like,
Okay.
has
Then
been so many
solve it.
weeks and it just got rustic.
Okay. And what is the good thing about this document? It has a few things. Few solutions are given how to calculate all these things. Okay, so you can also use this. If anything you will get problem, you can tell me in the next class. I will try to.
Yes, sir. Okay.
So this is the basic thing for eigenvalue, eigenvector. Okay. So you are started with the statistics, right?
Yes, sir. We did not started, so we have gone quite. We have finished histograms and also we are now in binary. We finished the rest, sir. Mean, median, mode, standard deviations, variance.
Okay. So you know what is the histogram and all. You
Yes,
have
sir.
the idea. I also show you how to calculate, how to create histogram or bar graph using MATLAB. Okay. So any probability distribution ma'am taught you?
Probability distribution as in, sir.
So ma'am has covered mean, median, mode, the central tendency, and all those things, right?
Mean, median, mode, box plot, histograms.
Okay.
These should.
So can you please tell me what is the histogram?
Histogram is a visual display of the data that we have, sir, from a range to, like, in this example, if it's from -2 to -1, how much of the frequency it has attained. So by seeing that, we can interpret
Yeah.
if it's right skewed or left skewed or if it's symmetric.
Okay. Uh, so, what do you mean by symmetricity of any distribution? Like you told about right skewed or left
Yes,
skewed?
sir. On both sides, it's equally declining, sir.
No, if it is equally declined, then we'll tell it not skewed, or we
Bell.
tell it's normal. It's kind of bell-shaped curve.
Yes, sir.
So you know about the basic of probability theory? I mean, you taught in class 12, but you may forget something about it. You just have to some basic. You can also study. Okay. So so I am just today I will just discuss some of the basic theory. Next day I will show you in the MATLAB code, right? Because
Yes.
today all the people are not present here, so I'm discussing about, and it will be I think helpful for your exam also. So you see the screen? I mean these
Yes,
letters
sir.
are visible.
Yes, sir.
Okay. So first, so can you tell me what is the data? What do you mean by data?
Data is a value that has been given from a particular population usually. It can be
And what is information?
information, sir.
Yeah. What is the difference between data and information?
Usually data is what we collect from the information, sir.
Let's see. Uh, so in statistics, what we do with, I mean, in statistics subject, what we do with statistics? It is basically analyzing, visualizing the data, right? So we have to
Yes.
work with data and we have to find the information from the data. Suppose you are given a data of a diabetic, 10 diabetic patients you have. So you are given with their blood sample or glucose level of for 7 days or 10 days. So this is the data. So you got the data. Now you have to analyze that data and you have to find some meaningful information which will be useful for your clinical observation, or you can get some idea about what is the type of their diabetes or how much diabetic they are. So
Okay.
that is the information you have to extract from the raw data. So
Okay.
in this way, data and information are two different things. Data could be meaningful or it may not be meaningful for your particular purpose. Okay. But information is what we are actually looking for. So see, data are the individual pieces of factual information recorded and used for purpose of analysis. Okay. But information is a group of data that collectively carries a logical meaning. So data may not have information, I mean logical meaning, or it may have logical meaning or may not have, but information is must have some logical meaning. Okay. So so the basic difference, that what I'm trying to tell, that the basic difference is you can get some information from the raw data. And how you can get that information? By using statistical methods. And statistical methods you can use in any kind of data. Right now you can use biological data, clinical data, hospital data, all kind of data. You can use your statistical methods and you will get some information. Okay. Like in epidemic disease prediction or all those things, we are only analyzing the data. Then we found out some curve or some graphs. Then we can tell some information. So this is the severity of the case. This is how much spread has been happened. Okay, so all the information we get it using statistical methods by analyzing the raw data. So data, there are two types of measurement or two types of data. One is quantitative, one is categorical or nominal. So what do you mean by quantitative data? Quantitative data means some numbers. So you will get some numbers. Okay. That numbers may be continuous and that number may be discrete. Okay. So most of the cases it could be discrete. Like discrete data means, suppose per day what is the amount of glucose consumption for a patient, or what is the amount of any carbohydrate consumption for a patient. So you get a data for 10 days. So this is the discrete data. Now
Sir, is
yeah.
time to event data discrete data, sir?
Yeah, time to event data, I think discrete.
No.
Actually, there are so many kind of data. but the basic way you can get that is quantitative data or categorical data. So categorical data, that means suppose how much diabetic that patient is. So you can see, you can use some measure that is,
Grading system.
yeah, it is very
Grading
severe.
system. Pre-diabetic, diabetic.
Pre-diabetic, yeah, that you can use. So this is the categorical data, nominal data. So what is written? The possible response consists of a set of categories rather than the number. Okay, so it is
It
kind
only
of
falls
grading.
in that categories.
Yeah,
Yes.
yeah, and true, false. This also a categorical data.
Binary data.
Yeah, binary data. Okay, so binary data give you only the two option, either it is 1 or 0, that is true or false. This kind of
Yes, sir.
two options you will get. Okay, now in any data there must present some error. Now why error is present? Because how we can acquire the data or data acquisition process, in that process some uncertainty is present there. It must be present there. So that is why error creeps in our data. Suppose you are taking or you are measuring glucose of a particular body, you take in the blood sample, you measure that thing. But in your measurement there must be some discrepancy, or there must be something that will be, so just So actually, just off topic, something yesterday I presented my seminar topic. So here I am working in diabetes, type 2 diabetic. So there you can see the data that we have collected. It is the raw data, and we make a mathematical model to analyze this. It is visible.
Yes, sir, it is visible. So I'm seeing.
Okay. So this is the raw data. Okay. So this is for glucose data. This is insulin data. But it is it so what is the difference between continuous data and discrete data? So we collected this data, not we, actually some other guys have collected this data using the discrete interval of time. Okay. So but if we make interpolation using that data, then we can fill the gap. So we can, so that interpolation is a statistical method. So we want to, so suppose in this gap we want to know what is the sugar, what is the glucose level of that patient. So we don't have the data, but what we can do, we can fit it with a curve, and we can interpolate it, or we can approximate one value between these 2 points. But that process, that interpolation process, is a statistical method. Okay, so this is our raw data. So actually this is discrete data, because these data points are collected at discrete interval of time. But if we do interpolation, then it will become a continuous data. So, and now we fit our model. So we have calculated mathematical model, and we fit our model using this data, with this data. But see, not all the data points are fitted. So there is the difference between this model and this original data. So this difference we call error. Okay, so how this error present here? It may present, so maybe our model does not acquire all the physiological information for type 2 diabetes, or it could have that this data what we are taking, it not accurately we are taking. There may be some measurement error present in that. Okay, so that is why error creeps in. So we have to deal with error. So statistics, in statistics we don't get anything. So there is a difference between statistics and mathematics. Mathematics works with perfectly everything. So but statistics, we are dealing with errors. But we are trying to get a trade off that, okay, approximate this is, so we want to measure what is the error present in this measurement. That is very useful information for us. So we are interested we are interested to get an idea what is the error present. So we want to measure that thing. What is the error present in this? Okay, so that thing we can do using statistical method. So you get my point. This is the, I think, error.
Yes.
So it could be two kinds of error: random error or systematic error. Okay. And reliability, it means that how similarly a test perform over repeated administration. How much reliable your test. Suppose you designed one diabetic test. How much reliable your test method is. Okay,
Okay.
so that also you have to measure it with some statistical method, and you have to suppose you designed one statistical one diabetic test for glucose measurement, or you can measure any diabetic I mean anything, any index you are measuring. So you designed your own test apart from the conventional test. Then you have to tell statistically or using quantitatively, you have to state what is the error present in your measurement. Okay, and how your measurement is good with all the other classical methods. So that thing you have to use statistical method. So that is why statistical method is very handy while analyzing data set, any kind of data set
Here,
it could
which
be.
statistical method would be used, sir?
Where
Here, which statistical method would be used, sir?
in which case
In reliability?
there are I mean reliability itself is a statistical measure. So you can there are a lot of things, R square and all those things are there. Okay.
Yes.
There is also that is validity, all those things, but yeah. So we are interested in probability distribution. I think ma'am will taught you. I don't know. So probability distribution is defined by the formula that specifies what values can be taken by data points within the distribution and how common each value will be. So, okay, let me tell you in a simple way. Suppose statistics, we can divide statistics into two parts. One is descriptive statistics, one is interferential statistics. So descriptive statistics, first we are interested to calculate what is the, suppose you are, so okay, I'll talk probability a little bit later. First we are tending to central tendency. Suppose your class has 10 students, so or 100 students, your class. Now one test is conducted, and your test result, I mean you all the people, all the 100 people have some result. So now I want to know how good your class performance is. So how you will tell? You just simply find the mean, and you will tell, okay, average we got 56%. That means how you can get that number or mean? You calculate all the 100 students result
And
and
divided by.
divide it by 100. So it is, but it is a very bad measure for central tendency, because what happens? Suppose few people got 90 out of 100 and few people got 10 or 20 out of 100. Now, when you are telling that your central measurement is 56, so see how much error there is. One, those who got 90 or those who got 20, 56, between 56 and 90 and 56 and 20, there is a huge gap or the huge error. So these values we call outlier, these 90 and these 56, because there is a huge gap between our central measurement or central tendency measurement and the original value.
So, but outliers are actually, I mean, mean is actually sensitive to outliers, no?
Yeah,
So, mean
mean
and
is very
standard
much sensitive
deviation.
to, yeah, mean are very much, so that is why I am telling mean is a very bad, I mean, it is a very raw measurement of your central tendency. So what we'll do, there is another measurement for central tendency, that is median. What do you mean by median?
So,
So can you
50th
tell me?
percentile.
Yeah, so it is a,
It's a
in a,
centermost.
yeah, it is a very, I mean, in a simple word, median is the middlemost value. Middlemost value in your data. So first you have to sort your data either increasing or decreasing way. Then you just take the middlemost value of your measurement data or of your data. So here the effect, so you can eliminate the effect of outliers in calculating median. And now, can you tell me what do you mean by mode?
Mode is the highest frequency of the data value
Yeah,
available. So.
yeah, highest frequency of the data value. And okay, so these are the three basic measurement for mean, median, and mode. See, most frequently occurring value. Now we are interested. So after getting the central tendency of your data, then we are interested to measure how much your data is scattered around that central value. You understand? You have
Yes,
data
sir.
set.
Yes.
You calculated the central value of your data. Now you want to know what is the error present. I mean, what are the error present? The basic idea is those 100 students, how much their number is varied from the central value you want to, so how much your data is scattered around that center value. So you want to measure that thing. So for dispersion, we have these basic 4 methods. One is range. Range is a very simple method. It is the difference between your highest value and lowest value. So how you can calculate range of your value, data value? You just
Highest
calculate
value,
minus lowest value. So you will
lowest
get an
value.
idea that within this range, suppose your highest value is 90, lowest value is 10. So your range is 80. So you can get that idea that your value is scattered between 10 to 90. Okay. Another is interquartile range. So it is IQR. So ma'am told you this IQR.
Yes, sir. We learned about that also, sir.
Okay. So what is mean by IQR?
Uh, the middle part of the portion, so which is 75 percentile minus the 25th percentile, so we'll get the core of the data, sir.
Okay.
No.
Yeah. So
Q3
see.
minus Q1, no, sir.
Huh?
Q3 minus Q1, no, sir.
Yeah. So see, this is actually I don't have any kind of thing, so I cannot write it down. So that is why I have to use that Google. So see, anyway, yeah. Okay, you
Other
are
class
having.
starts, yes, sir.
Okay, your class now.
Yes, sir. We have biological physics now, sir.
Okay. So next day we'll discuss about more, and we'll try to plot all those things, all those statistical method in MATLAB also. Okay.
Yes,
Thank you for
thank you, sir.
attending class.